Solving for x in these practice problems, again, our goal is to make sure we're doing the same to the left side of the equation that we're doing to the right as we're attempting to isolate x. So in this first problem, to get rid of the plus 5, we're going to subtract 5 from both sides. That'll get rid of the 5 here and just leave me with x. When I do 6 minus 5, my final answer is 1. For problem 2, I'm going to need to subtract 2 from each side. That gets rid of the positive 2 and just leaves me with x. 11 minus 2 gives me 9. In problem 3, since we have subtraction happening on the left-hand side, in order to undo that, we're going to need to do addition. So the minus 4, we're going to undo with a plus 4. That's going to go away and give me x equals 3 plus 4, which is 7. In problem 4, we're going to need to add 8 to both sides. That gets rid of this and just leaves me with x. 2 plus 8 gives me 10. Problem 5, we're going to need to do in 2 steps. The first step is like we've done above, get rid of this 2 by subtracting 2 from both sides. That's going to leave me with 3x equals 15. This 3x can be viewed as 3 times x. So the same way when we had addition, to undo it, we did subtraction. We need to know that undoing multiplication means doing division. So here, since it's 3 times x, we're going to divide by 3 to get rid of that. What we did to the left side, we also have to do to the right side. So we're left with x equals 15 divided by 3, or just 5. In problem 6, we're going to start by subtracting this 1. That's going to leave me with 5x equals 35. When I divide both sides by 5, I'm left with just x on the left. 35 divided by 5 gives me 7 on the right. Here, I don't have terms that are unlike, so I can't subtract the x over here. I really want to make sure all the variables are staying on the left side. Since these are like terms that can be combined, I can say, well, if I take 6x and I add an understood 1 more x to it, that'll give me a total of 7x. I can then divide by what's in front of the x and get a final answer of x equals 28 divided by 7, which is 4. In problem 8, when I combine 4x and an understood 1x, I get 5x. If that's equal to 45, then 1x is equal to 45 divided by 5, which really means x equals 9. In problems 9 and 10, I'm going to need to combine parts of them that can be combined because they're like terms, and also make sure I'm not combining things that can't be combined. So in this case, this 2x and this 2x can be combined because they're both terms with x's. They combine to give me 4x. This 2 does not have an x with it, so it cannot be combined. It has to stay separate as a 2. This equals 38. When I then move the 2 by subtracting it, I get 4x equals 36. Dividing both sides by 4 leaves me with just x on the left and a 9 on the right-hand side. For the final problem, I can combine this 3x and this 5x. That'll give me a total of 8x. I can combine this 1 and this 18. That'll give me a total of positive 19. Now when I move the 19 to the other side by subtracting 19, it goes away and just leaves me with 8x on the left. On the right-hand side, 59 minus 19 leaves me with 40. I can then divide by what's in front of the x, 8. Those will go away and leave me with x equals 40 over 8, which is an answer of 5.